In this video, we're going to solve an equation that contains an exponential expression. We're going to solve the equation 4 over 3 times e to the x plus 1 equals 7. And there's a procedure for doing this that works pretty well. The first step is to isolate the exponential term on one side of the equal sign. In this case, our exponential term is e to the x. So we want to get that e to the x all by itself. Well, we can start by subtracting 1 from both sides. That gives us 4 over 3 times e to the x equals 6. Now we could multiply both sides by 3 times e to the x, and that gives us 4 equals 18 times e to the x. And now finally divide both sides by 18 and we get 4/18 equals e to the x. Okay, once we get to this point, we then take logs of both sides. Now, we always want to match the base if possible. If it's a base e exponential or a base 10 exponential, we'd use base e log or base 10 log. If it's some other base, it doesn't really matter. We would just use base e or base 10. In this case, it's a base e exponential. So we are going to use the base e log. We're going to take natural log of both sides, which is base e. ln, or natural log of 4/18 equals natural log of e to the x. Now there's a property that says we can move that exponent of x out in front. That's one of the log properties. And that's really why we use this procedure. The x gets moved out front in the next step. And that's step 3. Apply the power rule for logs to move the exponent out in front of the log. And that gives us natural log of 4/18 equals x times natural log of e. Now natural log of e turns into just 1. So what we really have here is natural log of 4/18 equals x times 1, or just x. So x equals natural log of 4/18. And on a calculator we get x equals negative 1.504 if we round it. Now we're going to look at an equation that has logs on one side of equals. In this case, we're going to look at the equation log base 10 of x minus log base 10 of x minus 1 equals 2. We're going to get a solution and round it to 4 places. Our first step is, if there's more than one log on one side of the equation, is to combine those logs together using the product or quotient rule. In this case, we can apply the quotient rule and rewrite base 10 log of x minus base 10 log of x minus 1 as base 10 log of x over x minus 1. And that's because the quotient rule says log of u minus log of v equals log of u over v. And this will equal 2. So there's our new equation. Now once we have the equation in the form where we just have one log equals something, we can rewrite it using the equivalent exponential form. In this case, our base is 10 and our exponent is 2, so we get 10 squared equal x over x minus 1, and 10 squared equals 100. So now we have the simple equation x over x minus 1 equal 100. We can solve that by multiplying both sides by x minus 1. And that gives us x equals 100 times x minus 1. Distribute out the 100, and we get a x equals 100x minus 100. And now add 100 to both sides and subtract x from both sides, giving us the equation 100 equals 99x. Divide both sides by 99, and we get 100 divided by 99 equals x, which is 1.0101 if we round it to 4 places. Now we need to check our solutions, because for this type of equation we often get non-working solutions. We do that by plugging our answer of 1.0101 into our original equation. We get base 10 log of 1.0101 minus the base 10 log of 1.0101 minus 1. We put that into our calculator and calculate it out, and what we get is 2.00004 on the left side of our equation equals 2. Well, it doesn't exactly equal 2, but it's close enough. And the reason we didn't get exactly 2 was due to the rounding we did. So we can conclude that our answer of 1.0101 is indeed our solution. We're going to look at one last type of log equation, and that's where you have logs on both sides of the equation. In this case, we're going to look at the equation natural log of x plus 2 plus natural log of x equals natural log of x plus 1. Our first step here is to combine logs together so that we can get our equation in the form log base a of u equals log base a of v. We do that by applying the product rule. We can combine the two logs on the left and write ln of x plus 2 plus ln of x as ln of x plus 2 times x. And then we'll have that equal to natural log of x plus 1. Okay, now we can apply the inverse property that allows us to unlog both sides. And the inverse property makes use of the property that if log base a of u equals log base a of v, then u equals v. We unlog both sides and we get x plus 2 times x equals x plus 1. Now our logs are gone and we can solve our equation and then check our solutions. And again, in this type of equation, we get a lot of extra solutions that don't work. Our equation, when we multiply out the left side by the distributive property, gives us x squared plus 2x equals x plus 1. We subtract x and we subtract 1 from both sides, and that gives us the quadratic equation x squared plus x minus 1 equals 0. You can't solve it by factoring, but we can use the quadratic formula, plugging the coefficients a, b, and c into x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. If you do that, you get x equals negative 1 plus or minus the square root of 5 over 2. So we have two answers there, and it's kind of tough to check those answers in the radical form. So to make things easier, let's just turn each of those answers into a decimal. If we plug negative 1 plus square root of 5 over 2 into our calculator, we get 0.618. If we plug negative 1 minus the square root of 5 over 2 into our calculator, we get negative 1.618. We plug each of these answers into our original equation, natural log of x plus 2 plus natural log of x equals natural log of x minus 1. Let's take a look at that second answer first, the negative 1.618. We see right away that that cannot be the answer because when we plug it into our equation, we get logs of negatives, so the values lie outside the domain of the log function. We cannot even evaluate that. So that second answer is out right off the bat. We then check 0.618, our first answer. We plug that in and we get natural log of 0.618 plus 2 plus natural log of 0.618. Does that equal natural log of 0.618 plus 1? If you plug that in your calculator, you get 0.4811 on the left side and 0.4812 on the right side. And those answers are close enough because we rounded our answers, and that's why we're just a 10,000th off. So we can conclude that our first answer of x equal negative 1 plus square root of 5 over 2 is indeed our solution.